Okay, 4 questions. Well, at least we could do number 3. That's going to be on Friday. Did you guys look at the examples? Are you sure? And if that's the case, why is number 5 on the board? Explain yourself. Okay, number 2. Write the equation of the line. Okay, first of all, you got to understand what's going on. Are you guys drawing a diagram? Here's a circle. The center is at 2, 1, and the radius is 3. Write the equation of a line that has a slope of 3/4, so it's going to look something like this, that is tangent to the upper half of the circle. So the slope is 3/4. So again, whenever you have a tangent line, draw the radius to the point of tangency. It's automatic. Do it. That's on the SAT cheat sheet. Okay, so what do you think we're going to use in this problem? The distance between a point and a line. The distance between this point and that line is going to be 3. But the only thing we know about this line is the slope is 3/4. What form does it need to be in order to use that formula? Okay, so do you guys remember that the slope of the line is always negative a over b? So therefore, the equation of this line is going to be 3x minus 4y plus c equals 0. Because the slope is negative a over b, which is 3/4. Okay, and so all you got to do now is use the formula. How do you find the distance between a point and a line? It's the absolute value of 3 times 2 minus 4 times 1 plus c all over the square root of a squared plus b squared. And we want that distance to equal 3. And now you can see this thing here, c, now we can compute that using this equation right here. And how many answers are there going to be? 2, because absolute value, right? So let's simplify this. This simplifies to 5, right? And then what does this simplify to? 6 minus 4 plus c. So we have the absolute value of c plus 2 is equal to 15 then, right? So therefore, c plus 2 is equal to plus or minus 15. So c is equal to negative 2 plus or minus 15, which is either 13 or negative 17. Box said that's the answer. No. The reason why there's 2 solutions is because isn't there another line with a slope of 3/4 that's tangent to the circle? Because that distance would be 3 also. But I want the one that's tangent to the upper half of the circle. So here are your 2 answers. You got 3x minus 4y plus 13 equals 0, or 3x minus 4y minus 17 equals 0, right? Because we got 2 values of c. Which of these lines is the one that's tangent to the upper half of the circle? How can you tell? These are 2 parallel lines. How do I tell which one is like higher? It has the bigger y-intercept, right? Right? The y-intercept of that one bigger than that one. So what's the y-intercept of this one? Set x equal to 0. What's the y-intercept of this line? 13 over 4. What's the slope of this, the y-intercept of this line? Negative 17 over 4. What's bigger, positive or negative? Wait, let me get my calculator. Oh yeah, positive. So this is the answer. So on the quiz, what if I ask you to write the equation of the line that's tangent to the lower half of the circle? All hell's going to break loose. Then you pick this one. Number 4, if you draw this picture, easy. Are you guys drawing pictures? Okay, we're going to the non-responsive mode again. Huh? Okay, we play that game? I'll play that game. Okay. So point P, negative 4, 3 is somewhere over here. So here's point P. It's going to be tangent to the circle at point Q, like that. Find the length of this segment. Well, again, draw the radius to the point of tangency because it makes a right angle. And then if you draw this in, ooh, right triangle. Do we know the radius of the circle? Yeah, it's root 30. And we know the coordinates of P, it's negative 4, 3. So can you find the distance right there between these 2 points? Yes, you do use the distance formula, which is 9 and 7. So that's 81 plus 49 root 130. So how do you figure out that? Use the Pythagorean theorem. X squared plus this squared equals that squared. So x squared equal 100, x equal 10. Well, it's actually plus or minus 10, but distances cannot be negative. Yeah, when you do analytic geometry problems, you want to draw a diagram. I mean, sometimes you don't need to, but if you're stuck, right? Draw a diagram, especially on the harder problems. Oh, now 6 appeared. You guys are something else. Now, number 5, this you know, the reason why I made examples is so you can follow it. There was an example just like, how many people looked at the examples? And was there a problem just like number 5? And you did it then, yeah? See? What about the rest of you? Quinto, Chad. Why do I even make examples? That's okay, I got paid for it. Okay, don't use them. Okay, so what do we have in problem 5? Okay, here is the line, 3x minus 4y plus 23 equals 0. Write the equation of the circle that is tangent to this line at the point negative 1, 5. So negative 1, 5. And it passes through the point 6, 4. Okay, now what do we need to write an equation of a circle? Basically, we're going to find the center and the radius. Yeah, so do we know what the center is? No. What do we want to call the center? HK. So I need to write equations so that I can solve for HK. Now, what should I do? Draw the radius to the point of tangency. It makes the right angle. Now, if these are 2 points on a circle, what can you say about the distance from the center to there and the center to there? They gotta be equal because they're both radii, right? So write that down. The square root of h plus 1 squared plus k minus 5 squared is equal to the square root of h minus 6 squared plus k minus 4 squared. So I have one equation, but there's 2 variables. So in order to solve for 2 variables, you need 2 equations. So that's one equation. So if I put this problem on the quiz, and the probability is quite high, it's going to be on the quiz. You get 1 point for that. Now I use another equation. Yeah, what's the slope of this line right here? Negative a over b, which is 3/4. So what's the slope of this thing right here, since it's perpendicular to it? Negative 4/3. Can I write an equation from that? Yeah, because use the slope formula. The slope from here to here got to be negative 4/3. So k minus y over x minus x got to equal negative 4/3. There's your other equation. Oh, Mr. Parker, it's just like the example you did. Duh. Why do I do that? Okay, so here you get 1 point, you get 2 points, you want the other 4 points, solve this. Can you guys take it from there, or do you want me to do it? Wait until then, do you want to read the example? Wait, in the example, didn't I set the 2 distances equal and then make the slopes negative reciprocal? Okay, I'll solve it then. You know, analytic geometry is basically all out. That's what analytic geometry is, solving geometry problems using algebra. If you want your algebra skills to ameliorate, you can't just copy off the board. Okay, now, you got to actually sit down and practice. Okay, now, I'm going to simplify this equation. I'm going to square both sides, multiply it all out. Okay, but I think I showed you guys this in the first quarter. Do you notice that when you multiply this out, you're going to have an h squared here and an h squared this, they're going to cancel out, right? And the k squared there and the k squared there are going to cancel out. So I'm not going to even write it. Watch what I do. 2h minus 10k is equal to 1 plus 25, no, plus 26 is equal to negative 12h minus 8k plus 36 plus 16 is 52. So you get 14h minus 2k equal 26, but you can divide by 2, so 7h minus k equal 13. So I don't care what you do. You can use your own exotic method, whatever, but you gotta get that. Okay, and over here, what would I do? If I were me, I'll cross multiply. 3k minus 15 is equal to negative 4h minus 4. So that's like 4h plus 3k equals 11. That's your other equation. So 4h. Why am I teaching you algebra 1? Now what? What do you want to do? You want to solve for k in this equation and plug it in there? Or do you want to multiply the top equation by 3 and then add? What do you guys want to do? Multiply this by 3. Okay, 21h minus 3k equal 39. Add 25h, the k's cancel out, equal 50. H equals 2. See how beautiful I make the problems come out? Now once I know h, what? Plug it back in. So right here. If I plug in 2 for h, k equals 1. Woo! So we just figured out the center of the circle is at the point 2, comma 1. Oh, I like to use that for the center. Yeah? How do I get the radius? What do you want to do? Do you want to use the distance from the center to there, the center to that point, or the distance between a point and a line? Any one of those three would work. What about just go point to point though? 4 and 3, 5. Come on. It's a 3, 4, 5 triangle. So once you know the center and the radius, you can write the equation. X minus 2 squared. Why am I even doing this? Y minus 1 squared equals 25, because that's the answer on the bottom. It's just algebra 1, but you gotta write the equations to set it up. Just like when we get to number 6. You gotta write the equations to set it up. Don't worry, when you get out of this chapter, if your algebra skills are not good by now, when you get out of this chapter, they will be. Either that or you will fail. Okay, write the equation of the set of points that are twice as far from 2, 1 as from 8, 10. Okay, now, see, this is what I'm talking about. This is the kind of problems you can see on the test. I'm going to describe some kind of conic section. You have no idea what it is. I mean, you know it's a circle because it's on the circle worksheet, right? But when you're taking the test, I'm going to say, write the set of points that are twice as far from here as from there. You don't know what it is, but you got to set it up. Okay, here's a representative point. How do I label it? X, Y. You guys got to learn to do this. It's twice as far from there as from there. In other words, this distance is double that distance. Because some people are coming in before school for help and they're putting the 2 on the wrong side. How do you find the distance between here and here? The distance formula. How do you find the distance from there to there? You use the distance formula. Okay, now, one of these is 2 times the other, so I've got to put the 2 somewhere. Do I put the 2 on the left or the right, or just roll the dice? Or flip the coin? You put it on the right! You have to multiply the smaller one by 2 to make it equal to the bigger one, right? You guys remember how to balance equations in chemistry? Multiply the bigger one by 2. And then it becomes way bigger than the smaller one. How can they be equal? So if you put the 2 on the wrong side, that's automatic minus 3 error at least. And then that's as far as I'm going to take you. You guys, this is just algebra. Square both sides. Just make sure you change that to a 4, right? When you square both sides. Complete the square and it's a circle. You guys practice the algebra. Okay, 7. Okay, this is a very important problem. Well, all of these are important problems. Here is the equation of one circle. Here is the equation of the other circle. Where do these 2 circles intersect? So you've got 2 circles. Where do they intersect? Well, there could be 2 answers, but there could be one answer if they're tangent to each other, or maybe they might not touch at all, right? But if I look at the bottom of the page, there's 2 answers, so got here. What do I do with these two equations? Yeah, well, some people set them equal, but then how about you subtract? Because if you subtract the equations of x, what comes out? 2x plus y minus 5 equals 0. Now, if you wanted, you could add the two equations, but what would happen if you add these two equations? What would you get? If you add these two equations, you would get 2x squared plus 2y squared plus 6x plus 3y minus 35 equals 0. That's a circle, right? If you subtract the equations, you get a line. What do you think the significance of this line is? Yeah, this is the line that goes through these 2 points of intersection like that. If you add the two equations together, you get a circle. And so basically, you get another circle that goes through these 2 points. Isn't it easier to work with a line? So now that I got this line, how do I find these 2 points? You find where this line intersects one of these 2 circles, right? Look at the picture. Where does this line intersect this circle? At those 2 points. Where does this line intersect that circle? At those 2 points. How do you find where 2 graphs intersect? Let's go back to algebra 2. You solve for one variable in one equation and plug it into the other. So solve for which variable is easier to solve for? Y. So y equals negative 2x plus 5. Take this and plug it back into one of these. Which one looks easier? The second one, because it's got smaller numbers. Okay. So x squared plus y, but substitute that for y, plus 2x plus y minus 15 equals 0. And then look, come on, just take it from there. And you know I made this problem come out nice, so you know it's going to be factorable, right? You don't have to use quadratic formula. Well, or do you? No, look at the answers on the bottom, they're nice. You guys like the high voice, yeah? Oh, going back into non-responsive mode again. Hey, you're going to play that game the whole semester? How far are you going to take it? Okay, you guys finished that problem. Like, so, come on, man. I think this problem might be on, I don't know which one's, okay, so we're going to have 2 circle problems on the quiz. Well, you already know number 3 is going to be one of them. And you're going to have 1 parabola problem. Okay, today we're going to learn about parabolas. I already kind of, I'm sensing already, we might have to go to plan B early this year already. Whoa. Okay, what is the definition of a parabola? A U-shaped thing. No! Some of you still think any U-shaped thing is a parabola? No, I already told you, if you have 2 points, and then you have a rope or a chain, and you hang it under the influence of gravity, what is that shape? Remember in the second quarter I told you? Impress your physics teacher? This is called, it's a hyperbolic cosine function. I guess you didn't impress your teachers yet. It's called a catenary. It is not a parabola. So just because it's U-shaped, okay, what about the San Francisco, what do you call that thing? The bridge in San Francisco? Yeah, the Golden Gate Bridge. So you have, you know how the Golden Gate Bridge is like that? You have these things like that. And is that a parabola? Yes, that one is a parabola. You guys, what's going on? Okay, if you look at your notes, the definition of a parabola is the set of points in a plane that are equidistant from a given point and a given line. So, if you have a given point and a given line, a parabola is the set of points that are equidistant from the two. Does that look, that's kind of a, redraw that. Equidistant from the two. Yeah, that's better. You guys learned this last year, yeah? What is this point called? The focus. What is this line called? The directrix. And what is that point called? The vertex. So it's the set of points. I'm not going to derive these because I'm sure you derived them last year, plus it's in your Algebra 2 book. But if you were to derive it, this is how you would do it. Here's a representative point P. Okay? If by definition, the distance from here to here gotta equal to the distance from there to there. These two distances gotta be equal, and then that's how you derive the equation of the parabola. But these are the two standard equations of the parabola. X minus h squared is equal to 4p times y minus k. This is all in your notes, you know. You don't have to copy this down. 4p x minus h. So if the x is squared, the parabola either opens what? Up or down. If the y is squared, then it opens either left or right, right? How can you tell? You look at p. If p is positive, then this one opens up. If p is negative, it opens down. And let's make a chart. P is positive, p is negative. In this equation, if p is positive, it opens to the right, but if p is negative, it opens to the left. And what is the significance of p? What you guys remember from last year? P is the distance between the vertex and the focus, that's P. And it's also the distance between the vertex and the directrix, because these two distances gotta be equal, right? What do you call this? This line right here. The axis of symmetry. What do you call a segment that goes through the focus perpendicular to the axis of symmetry and the endpoints lie in the parabola? This is called the lattice rectum. Not lattice. The lattice rectum. Now, you guys in Latin, what does lattice rectum mean? Mr. Schron said he taught that to you. Who's in Latin? Wait, who looks like they would be in Latin? I don't believe you. Here, you look like you would take Latin. Leon. You guys have an answer for everything. Anyway, Mr. Schron told me lattice rectum means wide butt. That's what he told me. I guess it kind of makes sense, right? Anyway, the length of the lattice rectum here is equal to 4p. Can you see why? Look at this picture. Can you see why the length of the lattice rectum would be 4p? Come on, you guys did this last year. Because, okay, look. If this is a point on the parabola, then shouldn't the distance from here to the directrix equal to the distance from there to the focus? What is the distance from here to the directrix? If that's p and that's p. That's 2p. Therefore, this has to be 2p. But by symmetry, that has to be 2p. So the whole thing got to be 4p. Oh, so Mr. Park, this number right there is the length of the lattice rectum. You bet your sweet bippy it is. Okay, now, this is review now from last year. Okay, I'm going to keep those equations up. Okay, find all the important parts of this parabola. Okay, then let me give you one. A y squared plus 3x, no! 2y squared plus 3x plus 4y plus 5 equals 0. Just make up some numbers. How do I know this is a parabola before I even start? Because it has either the x squared or the y squared in it. You can't have both to be a parabola, right? And which one is this? Is this the up and down one or the left and right one? This is the left and right, that's the y squared. Okay, in order to find all the parts, you have to complete the square and put it into standard form. So what's the first thing you should do? Divide everything by 2. Okay, but let's combine steps together. Divide everything by 2. Put all the y's together. Put everything else on the other side. See what I did? What number do I have to add here to make a perfect square? 1. Make sure you add 1 to both sides. So you get y plus 1 squared equals negative 3 halves x minus 3 halves. Is that standard form yet? Well, the left side is, but the right side is not, right? So what do I have to do to the right side to put it into standard form? You got to factor out a negative 3 halves. Whatever the coefficient of x is, that's what you factor out. And what's going to be left? X plus 1. Now we have standard form. You see this thing here? That's 4p. The length of the lattice rectum is 3 halves then. Not negative 3 halves. 3 halves, because length cannot be negative. Yeah. That negative sign is just telling you that it's opening to the left, because this is a left, right one. So we know the parabola opens to the left. We know the vertex is what? -1, -1. Here's the focus. Here's the directrix. Okay, so if 4p is equal to -3/2, what is p equal to? -3/8. Now, the negative sign is just telling you it's opening to the left. So the actual distance is 3/8, right? So the distance between the vertex and the focus is 3/8. So if you're at -1, -1, and you go 3/8 to the left, where are you going to be? -11/8, comma, -1. That's the coordinates of the focus. And to get to the directrix, you go 3/8 to the right. So what's the equation of this directrix? X equals -1 plus 3/8, -5/8. Notice that the directrix is a line, so you're going to write an equation of a line, because some people write a point. It's not a point, it's a line. It's a vertical line. Okay, what are the other important points of the parabola? The endpoints of the lattice rectum. Here is the lattice rectum. Well, we know the length of the lattice rectum is 4p, which is 3/2. So if this is 3/2, what's this? 3/4. It's half of it. So from the focus, if I go 3/4 up, where am I? -11/8, comma, what is -1 plus 3/4? -1/4. And then this is going to be -11/8, comma, what is -1 minus 3/4? There you go. That's all the important parts of the parabola. I guess if you want to do the axis of symmetry just for funsies, what's the equation of this axis of symmetry? Y equal -1. Ah, that's so banal. Pedestrian. Okay, so that's the review from last year. So what's going to happen is I'm going to describe a parabola. You have to write the equation. That's the kind of problems you're going to get on the test. So let's do one. Okay, write me the equation of the parabola with directrix y equal, give me a number. I'm just going to use the numbers you give me. Oh, creative. And it has focus, what? Give me the coordinates of a point. 2, no! Why do you guys want to deal with fractions? Okay, I'll just go 2, -3 then. No! -5 just for that. There you go. Now can you see it's going to come out nice? I don't know what you're talking about. Okay, here's the directrix, here's the focus. Now what is the key point in the parabola? No, what's the key point? It rhymes with vertex. Now wouldn't the vertex be like halfway in between? Because it's got to be equidistant, remember? So what are the coordinates of the vertex? 2, comma, what's halfway between -5 and 1? Take the average. Oh God, it took that long? Oh my God. Yeah, but one of them was negative, Mr. Park. So, this parabola. Oh, so we got the vertex. You can write, now this is an up and down one, so this means x is squared. So x minus 2 squared is equal to 4p times y plus 2. All I have to figure out now, what is p? Well, p is the distance between the vertex and the focus, which is 2. How far is it from -5 to -2? 3. So what is p? No, it's -3. Because it's opening downwards. See, that's the trick right there. You don't put the negative minus 2. So we know p is -3. Therefore, the equation of the parabola is x minus 2 squared equals -12 y plus 2. This is easy, Mr. Park. Challenge me. Okay, now look at number 6. I thought we were done with polar coordinates. We are just beginning. And then we're going to see it again when we do 3-dimensional stuff, which is in a couple chapters. You guys think you guys can just forget things like last year? Yeah, that's what math is, isn't it, Mr. Park? No! I keep telling you, you put it in your tool belt and you make your tool belt big. With lots of tools. But some of you still, I don't know, how many tools you got in your tool belt? Zhang. He's hoping for a number like, oh, I don't know, 27? A lot. I don't know, 2 might be a lot for some people, right? Like if you're a kindergartner, 2 is like way more than anybody else has, right? Okay, what am I talking about here? Oh, polar. Okay, I'm going to give you a secret now. Usually, normally, up until last year, I didn't tell them any secrets about this. But I'm going to give you the secret on the very first day. So you guys better take it and run. Okay, anytime you have an equation r equal EP over 1 plus e plus or minus e sine theta or cosine theta, that's going to be a conic section. Okay? So any equation that looks like this is going to be a conic section. Okay? Right now, you have no idea what E and P represent. I'll just tell you right now, E stands for the eccentricity. What's that? Okay, we're not going to learn that. We're not going to learn that until we study ellipses. Okay, so any equation that looks like this is going to be a conic section. So R equal, okay, silence. Silence. 1, okay, what do you have? I want to do something different from the homework. You have cosine. I'll do 1 minus sine theta, and what number do I want to put on the top? 1, then a 2, so it's got to be a multiple of 2, let's put 6 there. Okay, this is a, well, how do I know this is a parabola? Because it's in the parabola worksheet. However, when we take the test, one of the problems is going to have polar in it, and you're not going to know what it is. You got to figure it out. Is it a parabola, an ellipse, or hyperbola? Okay, this is a parabola. Find, okay, what do I do? Find the directrix of this parabola. So one way to do this problem is change this to a rectangular equation, like we did when we studied polar. Remember that? But that takes too long. Okay, I'm going to give you the secret right now. Would you guys even remember how to change this to rectangular? I'll do it just for the video. You cross multiply r minus r sine theta equals 6. Hey, use some body. That's y. So r equals y plus 6. You square both sides, so you get r squared equals y squared plus 12y plus 36. But r squared is equal to x squared plus y squared. But the y squareds cancel out, and now you can see you get a parabola, right? And then you complete the square to put it in standard form. Okay, but yeah, that's the barbaric way. I'm going to teach you the secret. You guys better thank me now. Because otherwise, you're going to keep doing that, and then there's a secret. What did I tell you when we studied polar? What's the fastest way to graph these conic sections? Plot the 4 quadrantal angles. 0, pi over 2, pi, 3 pi over 2. You know, you got to think polar now. Okay, 0, plug in 0. 6. 1, 2, 3, 4, 5, 6. Pi over 2. Undefined. Someone will say, what? 1 minus 1 is 0. 6 over 0 is undefined. Okay, plug in pi. 6. So you got to go 6 in that direction now. 1, 2, 3, 4, 5, 6. And 3 pi over 2. 3. So 1, 2, 3. Do you see the parabola? Ooh. That's ugly, but that's the problem. Okay, fine. Now, whenever you have an equation in this form, see, this is the secret that I never thought, well, I did teach it, but I wanted you to discover it. But anyway, I'm just going to tell you, anytime the equation is this form, one focus is always going to be at the origin, at the pole. That's how these equations are derived, that's why. So you already know this is the focus. So once you know that's the focus, where's the directrix going to be then? Yeah, because look, here's the vertex. You have to go 3 this way to get to the focus, so don't you have to go 3 this way to get to the directrix? Because those distances got to be equal. So tell me, what's the equation of the directrix? Y equal -6. But see, if you don't know that, then you got to complete the square, and you got to do the 4p thing. It takes too long. But If you know it's going to be a conic section and the focus is at the origin, it makes life so much easier. So that's like an Iolani secret. So if you have friends who go to other schools, especially if they're on the math team, you cannot tell them this. Otherwise, if I find out, then one night when you're sleeping, you're going to think you're getting choked. You know when you can't breathe like that? You think it's a nightmare? It's not a nightmare, it's me. Okay, and so tonight is all parabola. I don't know, students can handle circles and parabolas. I don't know, when you get to ellipses and hyperbolas, something goes wrong though. Something just snaps. Okay, we're done. You have 8 minutes remaining. Oh, by the way, most of you are going to get iPads today. This should be one of the first apps you put on there, Pocket Cast. Okay, it's a free app. Well, there's two. There's a free one, and there's one you got to pay $10 for. Get the free one. This is like a graphing calculator. So it's a graphing calculator right on the iPad. Remember how I told you? Okay, how do you solve any equation on your calculator? What do you do? What do you do? You make one side 0 and you graph it, right? Woo! Okay, and then if you have a TI, how do you calculate that 0? You got to calculate 0, left bound, right bound, gas, da, da, da. How do you do it on the what's the other one called? The prism. G solve 0, right? Yeah, but you know when you do it on the Pocket Cast? Just touch it, boom. You want down? Just touch it, boom. You want down? Touch it, boom. You want the y-intercept? Boom. Okay, so down, get that app. That's your homework. The free one. If you want to pay for the deluxe one, you can. You don't really need it.